again and explain. So today we are going to learn the part 3 of our second test paper. So here we are trying to find the matrix multiplication. So that's why here there is two matrix given. So we have to go from left to right and then top to bottom. Okay. So if we multiply this way, like the first entry here is 4, and from top to bottom, the first entry here is 7. So 4 multiplied 7, it will be 28. And then plus 3 multiplied 2. So we go from left to right. So 3 multiplied 2, it will be 6. And then plus on multiply 1, it will be 1. So here we get 35. And then for the second entries, we do the same. So it will be 7 on multiply 7. So it will be 1 multiply 7. So that is 7. Then 2 multiply minus 2. Okay. So we go from left to right and then top to bottom. So 2 multiply 2 is minus 4. And then 3 multiply 1 is 3. So it will be 6. So, and for the last row here, so 5 multiply 7, 35. Then 7 multiply 2 is 14. And then 0 multiply 1, that is 0. So it will be 49. Okay. So as we see here, the first matrix, it is a 3 by 3 matrix. And then for the second matrix, it is a 3, sorry, for the first, 3 by 3 matrix, and the second matrix, it is 3 by 1 matrix. So we know that if we want to multiply two matrix, then the column of the first matrix and the row of the second matrix, they needs to be same. Okay. So you see here, column of the first matrix and row of the second matrix, they needs to be same. So they are same, and the rank will be, the size will be the row of the first matrix and then column of the second matrix. Okay, it will be the size of the matrix multiplication. So we can say that this matrix, the multiplication for this matrix, the multiplication or the result, it will be a 3 by 1 matrix, right? As we can see here, it will be a 3. So it will be a 3 by 1 matrix. So for this reason, I just write down this way. So this is our result, and then we write down this way, a 3 by 1 matrix, 35, and then 6, and then 49. Okay. So this is the result for the first matrix. And for the second matrix, it is a 1 by 3 matrix. And this is a 3 by 1 matrix. So as we see here, we have the number of column of the first matrix and number of row of the second matrix, they are same, right? So we can multiply this matrix, and then the result will be a 1 by 1 matrix. Okay. So if we multiply this way, like from left to right, so 1, and then top to bottom, so 1 multiply 3, so 3, plus 2 multiply 2 is 4, and then plus 3 multiply 1 is 3. So it will be 11, right? So sorry, it will be 10. So this is our result for the second question. So now let's see here. So here we have to find the inverse matrix through elementary row operation. So for this reason, we have to write down this matrix into so this way. We have to write down the corresponding identity matrix on the right side, and then our main matrix on the left side. And then we have to perform row operation and convert the left part to an identity matrix. Okay. So we have to convert the left part into a RRF or into a identity matrix. So if you do row operation, You can see here I have done row operation. So at last you will get an identity matrix on the left side, and so your result or the inverse matrix, it will be on the right side. So this part here, this is our inverse matrix for A. So you can write down A inverse is equal to 530 minus 3 minus 20 and minus 3 minus 3 1. So this is the formula, like a matrix A multiplied with the inverse matrix is equal to the inverse matrix multiply A. I mean here it is dot product, right? So we can just write down this way. So it will be an identity matrix. Okay, if we multiply a matrix with the inverse matrix of that same matrix, so we will get an identity matrix. So this was the formula, and that's why we get our inverse matrix here. Okay, so I think you can understand this part. And then let's go to the third question. So the third question here is, okay, solve the following linear system by Gaussian Jordan elimination. So for this reason, we have to take the coefficient of x1, x2, and x3. Okay, and also we have to take this constant. So as you can see here, I have taken the augmented matrix for this linear system. So here, okay, and then we have to do row operation and convert it into RREF. Okay, so you can see here we have our first pivot point here, second pivot point here, and the third pivot point here. So this is a RREF form because all the pivot points, they are 1, and the value below and above those pivot points, they are 0, right? So that's why you can say this is the RREF form. So this is a RREF form, right? And then we have to write down the value of x1, x2, and x3. Okay, so if you look here, this part, okay, this 1, minus 2, and 0, they came from the constant, right? Or you can say like this was our this was I mean d, okay, d or something like any constant. So it was at on the right side of the equation. So that's why we are if we write down here x1 here, x2 here, and x3 here, so you will see that x1 multiply 1, that means x1. So I have written here x1, and on the right side we have 1, right? So I can write down here this way, x1 is equal to 1, and then on the second row we have x2, I mean on the second column we have x2, and there is 1. So this is we can write down here x2, and then for x2 our value is minus 2. So I have written here minus 2. Okay, okay, fine. And for the third column we have x3. So here is 1. So 1 multiply x3. So 1 multiply x3, that is x3, and right side we have 0. So x3 is equal to 0. So this is the solution for the linear system. Okay, for this linear system. So this way we find the solution of a linear system by Gaussian Jordan elimination. So guys, can you understand this part?
Yes. Yes.
Okay. So now let's go here. We have to evaluate the determinant. Okay. We have to evaluate the determinant of this matrix. So okay. So the formula is we have to do some row operation and make all the entries below the main diagonal as 0. Okay. So if you look here, we have some similar entries here. here is x minus 1, and here is you see here is minus 1, here is minus 1. Okay, we have a lot of minus 1 here, right? And so if somehow we can make all the entries of a specific row or column, uh, all the entries same, like here as you can see, I have got x minus 3 here, x minus 3 here, and x minus 3 here. That means all the entries of this row they are similar. So then our calculation will become easier. Okay, so let's see how can we make this. So if we add the first row with the second row with the third row, then okay, so then we will get, so we are adding the first row with the second row. So x minus 1, then we have minus 1, and then also we have minus 1, right? So minus 1. So you see here I have written the entries here. Okay, so I have done this row operation, r1 plus r2 plus r3. So x minus 1 minus 1 minus 1, it will be x minus 3. Okay, and the same way here. So here is x minus 1, right? You can see all the entries of the main diagonal, they are same. So now if we add this entry, and this entry, so again we will get x minus 3, and then for the last column we will also get x minus 3. So we are putting this value into row 1. Okay, so I had to write down this way, r1 plus r2 plus r3 is equal to r1. That means I am putting the result in r1, and I am doing the calculation in row 1, row 2, and row 3. So as you can see, we didn't change the second row and the third row. Okay, the second and third row, they are the same as before. So now let's see what can we do from the in the next line. So in the next line we can just divide the first row by x minus 3. Okay, so if we divide the first row by x minus 3, so we can just say like we take x minus 3 out of the first row. Okay, that means we have to multiply x minus 3 on the we have to multiply x minus 3 here, and then we have to divide x minus 3 with all the entries of the first row. Okay, x minus 3 and x minus 3. Or you can just imagine simpler way, you can take x minus 3 as a common. Okay, I think that's the easiest way to think of. Or you can you factor out x minus 3. So as you can see, you factor out x minus 3, and then you will get all the entries of the first row, it will be 1, right? So I have done this row operation, and I have put in the value in here in the row 1. Okay, so now let's see what can we do in the next line. So you see here, we have minus 1 here and also minus 1 here. So we have to look for the same entries. Okay, we have to look for the entries where their value is same. So I mean the plus minus sign doesn't matter. Like if there is if the sign is different. So for example, here is plus 1 and here is minus 1. So you can just add the first row with the second row. Okay, and then you can substitute the result in the second row. Then you will get 0 here, right? You will get 0 here. And if it is and if their sign is the same, like here is minus 1 and here is minus 1, so you just subtract the second row from the third row. Okay, or you can do this way, like you subtract third row from the second row. So anything is okay. Okay, so we have done here, like we have x minus 1 minus 1, that is 0. So yeah, So we have done this row operation, R2 minus R3. And we have put in the value in R2, okay, in R2. And then we will get, so minus 1 minus minus 1, it will be 0. So here is 0. X minus 1 minus 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 1. So it will become, you will see x minus 1 and then minus minus 1. So it will become x minus 1 plus 1. That means x minus 0 or only x. And for here it will be minus 1 minus x plus 1. So it will be again minus 1 minus x minus 1 minus x plus 1. So it will become minus x. Okay, so if we do the reverse reverse way, like R3 minus R2, R3 minus R2, so it will become 0. So minus 1 minus 3. Okay, yes. It should be minus here, right? If I do R2 minus R3, it should be minus here. It will be, oh yeah, it was minus, like as I draw the main diagonal. Oh no, so it was minus or not. Let me see here in the question. Where is the answer of last year? Okay, so I think it will be minus here, okay, because if you do this way, like R2 minus R3, so it will be minus 1, then minus x plus 1, right? Because if you add a minus, if you multiply a minus sign with x minus 1, so their sign will get reversed. So you will get minus 1 minus x plus 1. So then the result, we can cancel out plus 1 minus 1. So the result is minus x. And then you have to multiply. So as you see here, we have a 0 here and we have another 0 here. And then we have to look at here, okay? We still don't have a 0 here. So we need to do some row operation so that it becomes 0. So if you do this row operation, like R1 plus R3, okay, R1 plus R3, and then substitute the value, substitute the result in R3. So it will be R1 plus R3, and then you put the value in R3, okay. So you will get on plus 1 minus 1, it will be 0. And then 1 minus 1 plus minus 1, it will be 0. And then on, okay. Then on plus x, on plus x minus 1, it will be also, it will be only x, right? Oh yeah, now I got it. So it will be x here. Yeah, it was correct, okay. It should be x. So, oh yes, we were substituting the value in row 2. So it was 0, x, and R2 minus R3, right? So, oh, I think there is some simpler way. Or in this, for this example, they didn't do R2 minus R3. I think they did R1 plus R2, okay. And then they substitute the value. Okay, so we already did did it in the first case, okay. And then here minus 1. No, I think it's okay. So on plus minus 1. So if we do R1 plus R3, oh, okay, fine. Guys, I think you understood this row operation, right? R1 plus R2 is equal, then we R1 plus R2, then we put the then we write down the result in R2. So I think you understand this part, right? This part. And then
Yeah.
for the last row here, we have done R1 plus R3, okay? And then we substitute the value in row 3. So 1 plus minus 1 is 0, and then 1 plus minus 1, this is also 0, and then 1 plus x minus 1, it will be x. So I think now it's okay, right? So if you do this two row operation, you can get a triangular matrix, a lower triangular matrix. Okay. So for a lower triangular matrix, the determinant will be the multiplication of the entries in the main diagonal. Okay, as I have marked here. Guys, can you see? So this part,
Yeah.
the multiplication of the row
Oh.
in the main diagonal, it will be the determinant of this particular matrix. Okay, because we have got a triangular matrix here, because you see here a lower triangular matrix. This is the main diagonal, and all the entries below this main diagonal, they are 0. That means it's a lower triangular matrix. So that's why